I'll be discussing uh, the design of Turing machine for language of palindromes over sigma is equal to AB. So in this language, different possible strings are. These strings may be either even length strings or the odd length strings. So palindrome examples. So this is one. The second one is AA. Then the third one, which may be ABA, or it may be AAA, or it may be BBB. And that way the palindrome strings are the ones whose reverse is equal to the string itself. So we'll be designing Turing machine which will reach the accept halt if the string is palindrome over the sigma. So working of Turing machine, or the logic for design of Turing machine, will be like this. If we consider the string A, B, B, A, which is even length string, so tape head, here tape head which is initialized to the first blank, and we assume there are multiple blanks after the last symbol. So tape head is initialized to the first blank. So with the first blank it will go to the first symbol. If it is A, then it will search for matching A at the end, and both the A's will be replaced by X. Then it will come back again to the first blank, start searching for the next symbol. It will find the next symbol to be B. If it is B, then again it will go to the last blank and start searching for the matching B. It will find matching B here, and both the P's will be replaced by Y. After making it Y, it will come back to the first blank, and here it will start searching. Now here A is replaced by X, B is replaced by Y, B is replaced by Y, and A is replaced by X. So it will reach this blank. When it reaches this blank, it means that it is the even length palindrome, and with this blank it will go to the accept halt. Now if we consider another example, suppose it is A, B, B, A, and it is A, B, B, A, which is a palindrome. So here first A after the first blank, it is replaced by X. Now it is searching for the last A. So last A it will find it here, which will be replaced by X. Now again it will come back to the first blank, start searching for A or B. It finds B here. So this B is to be replaced by Y. Again go to the last blank and start searching for matching B. It will immediately find the matching B, which will be replaced by Y. Again it will come back to the first blank, and from this blank it will start searching for the first symbol. It will find B here, which is replaced by Y. Again go to the last blank and start searching for the B. It will find B here, and it will be replaced. Similarly, this is X and this is X. So here all these symbols, A has matching A, B has matching B, B has matching B, A has matching A. So it is even length palindrome. So with this blank it will go to the accept halt. Now another example, suppose it is A, B, A. Now in this case what will happen? For A it will find the matching A, but for this B it will not find the matching B because it is odd length palindrome. So for this B, when it is searching for matching B, it will not find the matching B, but it will find a blank. This blank it will find basically. So blank, when it finds, with the blank it will go to the accept halt. This is in case of odd length. So in case of odd length, when it is searching for matching symbol, if it is not finding it, it will go to the accept halt. Now if it is okay, so we'll take some example where it is not a palindrome. So if we say AB, AB, so here what will happen? A, which is replaced by X, and when it is searching for the corresponding A, instead of A it will find B here. So because it is not matching here, with this input B it will go to the reject halt, or it will crash there. So this will be the logic. Now we'll design the Turing machine. So design of Turing machine, here the input tape is considered, where a sample input string is stored on the input tape, and this is the finite control. So as I said, the first input will be the first blank. So it will just read the first blank and go to the state Q1 by taking a right move here. Now it is in Q1 and tape head is at the position A. So if it is A is to be replaced by X and take a right move which is going to state Q2. Now after making, I'll write down this string here. After making this A to be X, now it has to search for this blank. So while searching for this blank on the path, it may find any number of A's, any number of B's. So for all of them, it has to keep moving right. Like for B, it will read it, move right. B, read it, move right. And A, move right. So here it will find a blank. So if it finds a blank, then it will take a left move, and now it is in state Q3. So after reading this blank, it has taken a left move and input is A and state is Q3. So for A, it has obtained the matching A. If it finds the matching A, it will be replaced by X, and now it will take a left move which is in state Q4. Now in state Q4, it will be in state Q4 and it will keep moving left till it finds this blank. So on its way to leftmost blank, it may find any number of A's, any number of B's, it may find X, it may find Y. For all of them, it will keep moving left, and with this blank, it will go to the state Q1. With blank, it will go to the state Q1 and take a right move. Now in state Q1, when it is in state Q1, here input is X. So for all X and for all Y, it will keep moving right, and now input is B. So if input is B, similarly, it will replace B by Y and take a right move which is in state Q5. Now after making B to be Y, it will start searching for the last blank, and for searching for the last blank, it has to keep moving right for all A's and B's. It may also find X on the path and it may also find Y on the path. Similarly, here it may find X on the path and Y is on the path. So for all of them, it will keep moving right. So when it reaches to this blank, it will take a left move here, blank to be kept as blank, and take a left move. So here in the state Q6, when it takes a left move, it will find this X. So for X, it will wait, and it may also find Y as well. Similarly here, it may find X and it may find Y. So so here it will read X, it is in state Q6. Here it finds B. So if it finds B, then with B, it will go to the state Q4 by making it Y, and it will take a left move. So this is how, so this part is for matching A with the last A or B with the last B. Now accept halt. This is some accept halt. So from state Q1 with blank, it will go to the accept halt. Similarly, in state Q3, instead of finding A, if it finds a blank, it will go to the accept halt. Similarly, for Q6, if it finds a blank, it will go to the accept halt. So this is for odd length. This is as well for odd length palindrome, and this is for even length palindrome. So with this, in case of even length, it will reach the accept halt, and in case of odd length, here when middle symbol is B, it will take this move to reach the accept halt. When middle symbol is A, it will take this move. So for example, if it is BAB, then with this A, For this A, it will come to the except halt, and if it is ABA, if we consider this as a string, then with this B or with this middle symbol, it will come to the except halt. So this is the design of Turing machine for language of palindromes, which is asked in the examinations for 12 marks. So it's important question.